You probably remember something like this when we looked at sum and difference identities. Remember? Look at what you have here and try to match it up with something here. Okay, so read the question. First thing it says, express each as a single trig function. That's why you're going to use the identities. Okay, and then give the exact value if possible. Okay, so we can figure that out. So all we have to do now is just match. Look, I've got a 2 up front, sine cos. Look what I've got. 2 up front, sine cos. It's the first one. So all I have to do is say, okay, this pi over 3 and pi over 3, they match. So there's my a's. There it is. All I have to do is say, oh, well, that's simple. That's sine of 2 times pi over 3, which results in, of course, sine of 2 pi over 3. Gee, I wonder where that is. Yeah, 2 pi over 3 has got to be that guy right there, right? You know that that's 2 pi over 3, so what's the sign of that? Well, that's negative 1/2 root 3 over 2. So our answer here then is simple. It's root 3 over 2. There's our answer. Done. Oh my goodness, is it that simple all the time? Yes, just match them up. Look at this one. This one says 2 cos squared of some value minus 1. So look, it's right here. It's right here. 2 cos squared of some value minus 1. What is that value? Oh, that value there, that must be our a value. Our a equals to 3. Oh, so what do? Just go and use this. Look, this now becomes cos 2 times whatever the a value was. You know that that a value was 3. So this becomes cos 6. Now, you know and I know, looking at our wonderful unit circle, we can't find an exact value of cos 6. So let's just leave it like that. Okay, so let's keep on doing the next ones. Well, hold on. I, of course, have to have my double angles in front of me. It's really important to have your formula sheet with you. Now, take a look at this one. Ooh, this looks kind of interesting. This one, in fact, says, check this out. This says cos squared sine squared of pi over 3. Where's cos squared sine squared? Oh, there's cos squared sine squared. Is it a subtraction like this one is? It is. Oh, I found the right one. Isn't that, oh, glorious. This is cos of 2. What's the a value? Oh, the a value is pi over 3. Okay, there's the pi over 3, which, wait a second, I've done this one 100 times, haven't I? Yes, I have. This is the cos of 2 pi over 3. Again, that's the narrow one. That goes right here. And that, of course, is going to be our negative 1/2 root 3 over 2. So our cosine of that is going to be just plain old negative 1/2. Oh, how glorious. Okay, let's do the same thing with this one. Look at this one. Even though the pi didn't really turn out, that's supposed to be a pi there. But check this out. This says 2 tan pi over 8, 1 minus tan squared pi over 8. Duh. I mean, that's the only tan one we got. So you're going to take that pi over 8 value, and it's just the a. So this is going to be tan of 2 times pi over 8. Oh, what does that give you? Well, that gives you tan 2 pi over 8, which is actually the tan of, wait till you see this one, pi over 4. And we know the tan of pi over 4 is just 1. That's that obvious one, right? Okay, so we're on a roll. Let's keep on going. Let's look how fast we can do these as long as we have that wonderful double angle identities right in front of us. Okay, so let's put it in front of us. There it is. Cool. Okay, so on we go to E then. Look at this one. This one's kind of tricky because if you notice, this says 10, this says 4x, that says 4x. Uh-oh, I got a problem here, don't I? Yeah, how does this look like anything? Well, surprisingly enough, it's actually this one. I'll prove it to you. Watch. Watch if I take this 4x and this 4x. Since they're the same, I'm just going to call it A. I'm just going to call it A. And look what I have. I have this 10 up front, but I have sine A times cos A. The only problem is it's not a 2. Well, actually, yeah. Break down the 10. Isn't this 5 times 2 sine A cos A? So look what I have now. Ta-da! I have this exact identity. Sometimes you kind of like, you got to get in there and kind of fiddle with it a little bit in order to make this look kind of like the identities that we're playing with. All right, just remember that the A was 4x. Okay, so what do we got here? The 5 still stays there. It still stays there. There's no problem with that. But what did this tell you to do? This told you that this is the sign of 2A. What was A? Here, let's erase it and I'll prove it to you. What was A? Oh, it's 4x. So this works out to be 5 times the sign of, oh, A was 4x. So 2 times 4x. This becomes 5. I'm going to extend the page here. 5 sine 8x. There's my answer. Isn't that cool? That is so cool that you can play around with this guy to get exactly what you want and solve it without any kind of questions. Oh, that's the beauty of identities. Let's look at F. Check this one out. Oh my goodness. Well, so what? This is a cos squared sine squared one. Well, there's cos squared sine squared right there. I can figure this out. What's the first thing I would do? First thing I would do is I'd notice that there's 3's in front of both of them. These guys have 1's in front of them. So factor out a 3. Look what I've got now. If I factor out a 3, I got 3 cos squared 1/2 A minus sine squared 1/2 A. Everything's beautiful, right? Yeah, so far. Okay. The only problem is, my goodness, I got a half here and a half here. Well, you know what? I'm going to call this B, B, and B because A is already taken in the question. So look, I'm going to make this into a B, right? So look what I have. I now have 3 cos squared B minus sine squared B, making it nice and simple. Ha, 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 ha. Look at that. Beautiful. Okay, so I got a 3 in front of that, meaning that this is going to be cos 2B. But what did I write in for B here? Do you remember what I wrote in for B? Yeah, it was 1/2 A, wasn't it? Okay, so let's just put it back. This equals to 3 cos 2 times 1/2 A. Oh my goodness, check this out. The 2's cancel. My answer here then would be 3 cos A. You might want to stop the podcast right there and back it up and watch this thing again because it's kind of freaky, isn't it? Yes and no. It's really, really cool how beautifully this works out. Okay, last question here before we run on to a really long podcast. There's the question. Again, I can't do anything until I have that identity sheet in front of me. Okay, so let's grab the identity sheet and put it in front of us. There you go. All right, so what do I got here? Looks like I got a sine x cos x. So let's go. Well, can't be that one. Can't be that one or that one. That's tangent. Blah. The only one that works is this one. But if you notice something here, we're missing a 2 up front. Wait a second. I've got a 1 up front here. I've just eureka moment right now. Look, if I take 2 and multiply it by half, does that not give me 1? So watch what I'm going to do. This is going to freak you out. I'm going to actually put this in front because if I put this in front, all I'm doing is actually multiplying it by 1, aren't I? So I want it to look like having a 2 up front. So guess what? I'm just going to rearrange this. 1/2 times 2. Watch this. 1/2 times 2. And look at this. Oh, those are the same. So I'm going to make them A's. So watch this. This is going to be sine A times cos A. Looks identical to that now, right? The only issue is you've got this crazy 1/2 up front. So what? So what? Here we go. 1/2. This is going to be, using this identity, is going to be 1/2 sine 2A. Well, what was A? Wait a second. Let me erase this. Let's see what A was. Oh, A was 5/2x. Okay, let's keep on going. A was 5/2x. Sine 2 times 5/2x. Oh, how beautiful. Look at this. Look at this. Look at this. This is going to freak you out. The 2's cancel, leaving 1/2 sine 5x. Done. That's how you do these kind of questions. It's a little bit of finagling things, but man, I tell you, there are so many cool things that I just showed you. Watch this podcast again. You'd really appreciate it if you did.